Let's first set up a differential equation. So it says that when a person dies, the rate of change of their temperature, so I'm going to use capital T for temperature, the rate of change of their temperature, in other words, the derivative, so there's rate of change of temperature, is proportional, so it's a constant times the difference between the temperature and the ambient temperature, in other words, the surroundings, which in this problem is a constant 50 degrees. Now we need to solve this differential equation. So this is separable differential equation. We can have the capital T's on the left side if you divide. So divide both sides by T minus 50, either with or without the parentheses. The right-hand side will have the time information, constant times dt, and then integrate both sides. On the left-hand side, this is the natural log. On the other side, it's going to be k times t, and then we need a constant of integration, c. Next, you could solve for t by exponentiating both sides. On the left-hand side, we're left with just capital T minus 50. And on this side, what's usually done is you break this up, use the rules of exponents that say if the exponents are being added, that's the same thing as having e to the c times e to the kt. Add 50 to both sides, and then we're going to plug in numbers to find out what k and c are. So we need some information like, when the person dies, their temperature was 98.6, which means when time is equal to 0, this temperature is 98.6. So if the time is equal to 0, this gives us e to the 0. E to the 0 is 1, so that just leaves e to the c. If you subtract 50 from both sides, you'll see e to the c is equal to 48.6. Usually we would go one more step and solve for c, but we don't need to because this says the number that goes in front is e to the c, whatever e to the c equals. So we can say, all right, our function is capital T equals a 48.6 e to the kt plus 50. And now there must be some other information in there so that we can find out what k equals. So k is basically the rate at which the temperature is dropping. That information isn't given directly, but there is this information that after 2 hours, it's 94 degrees. So put 94, 94.0, put 94 on this side, and a 2 for the hours, and then solve for k. So we'll need to subtract 50 from both sides. Next up is divide by 48.6. And then take natural log of both sides. So once you divide by 2 or multiply by half, it's going to be natural log of 44 over 48.6, and then multiply by 1/2, so we get k is a negative 0.5. Wonder if I could get a little more accuracy. Zero, 4, 9, 7. So I like to deal with 3 significant decimal places. So the 0 doesn't really give you any information, so 3 significant decimal places here. All right, we finally got our function. It is t equals 48.6 e to the negative 0.0497 t plus 50. Now what are we supposed to do with this? Oh, I guess that's it. Find the temperature of the body as a function of time.